Good afternoon, everyone. My name's Olivier, and I work on the Ubuntu Desktop Team at Canonical. And I'm going to talk about native messaging for strictly confined browsers. So, starting in Ubuntu 22.04, Firefox comes installed as a snap instead of the traditional deb package. I'm not going to go into the details of the decision-making process, but I just wanted to highlight that it does come with benefits for end users. Among other things, the snap is strictly confined, so that's an added security layer for the users. And also, very importantly, it is endorsed and published by Mozilla. So it is being published at the very same time that they publish their upstream releases. There's no more delay waiting for security updates to flow through the usual channels. Oh, and the snap runs on old releases of Ubuntu, including 16.04, for which it would be very inconvenient and hard to build debs because of the build dependencies being bumped all the time. Now, it's not just advantages, there are also some known shortcomings. Strict confinement comes with its own set of challenges, especially for applications that interact in many different and creative ways with the system, which is the case of browsers these days. It's not just about browsing web pages anymore. So one of the very visible regressions that we had when we transitioned to the snap was that native messaging stopped working. And just to be clear, native messaging is not about using instant messaging applications or SMS in your browser. It's a mechanism implemented by several major browsers that enables an extension to exchange messages with a native application installed on the user's computer. So this opens up a whole lot of possibilities. And from a security perspective, it's not necessarily a good idea, but that's a different topic. And there are plenty of interesting use cases for native messaging. Just to name a few, there is the GNOME Shell extensions management extension, which talks to a binary installed on the host. That binary is called chrome-gnome-shell. And it's able to list locally installed GNOME Shell extensions. It can install extensions, remove them, configure them. Another very interesting use case is password managers extensions, like, for example, KeePassXC or 1Password, which communicate with the native application to allow logging into websites without storing the credentials in the browser itself. If you don't trust your browser, that's a good alternative. So native messaging stopped working because the Firefox snap is strictly confined, and as such, it cannot view and spawn arbitrary executable on the host system. So what do we do about it? How do we go about fixing it? So my colleague on the desktop team, James Henstridge, proposed and implemented an XDG desktop portal that exposes a DBoss API that confined browsers can talk to and invoke to request launching a native host application by specifying the name of the native app and the unique ID of the extension. The portal is responsible for finding the manifest of that specific connector and verifying whether the extension is allowed to run it. If all the checks are okay, the user will be prompted the very first time that this specific connector is trying to, that this specific extension is trying to run this specific connector. And if the user agrees, then it will launch the native host connector. The portal itself spawns the executable and passes open file descriptors for communication between the browser and the connector itself. So you will note that I'm intentionally talking about confined browsers, not one specific browser, because the portal itself is not Firefox specific. Also, it's interesting that it should work across different confinement technologies, so not Snap specific. It should work under Flatpak, for example. So the portal proposal has received some feedback. As of today, it's not merged yet, but we had an interesting conversation today. And I'm hopeful that we can move this forward very soon. Despite not being merged yet, it has been available since Ubuntu 22.04 as a distro patch. So the next step was to, once we had this portal in place, was to modify Firefox to make use of the portal when running strictly confined, instead of the legacy code path, where it handles all the checks and spawning the native connector itself. So I worked on that part, and I got a lot of useful feedback from various Mozilla engineers who helped me get it into a state where it meets their standard for coding style and quality. It's a pretty large change. The diff is about 1,800 lines, and it hasn't been merged upstream yet, partly because Mozilla wanted some broader consensus on the portal itself first. Also because they wanted some more documentation written, which is on my to-do list. And that's because eventually they will commit to maintaining it in the Firefox code base, so they want to make sure that it's in a state where it's maintainable. But the good news is that last week they gave us the green light to cherry pick the patch into the Snap, into the stable release. It had been available in the beta Snap for quite a while, but it wasn't in stable. Now it's in stable since last week. So I'm happy to report that if you're running Ubuntu 22.04 or 22.10, native messaging should be working just out of the box. So let's have a quick look at how this works in practice. And then I will demonstrate it with a couple of extensions. All right, so Firefox is going to query the portal if it exists. Is the portal available? Yes. Then it will invoke create session with a unique name on the portal. The portal is going to return a session handle. So that session handle is a dbus object path for the session. Then Firefox calls getManifest with the session handle, the name of the native connector, and the unique ID of the extension. The portal is going to locate the corresponding manifest if it exists. It will also do some checks, so namely whether this specific extension is allowed to talk to this connector. And it will return the manifest as a JSON blob. Firefox does its own set of validation on the JSON. And then it calls start on the portal. Again, the same arguments, the session handle, the name of the native connector, the ID of the extension. The portal is going, if it's the first time this is being requested, the portal is going to ask the user for permission. And the permission is stored permanently. And then the portal is going to spawn the native connector executable and return open file descriptors to Firefox, stdin, stdout, and stdr for communication. From this point on, Firefox is talking directly to the binary that has been spawned without going through the portal. Right? And when the extension is done communicating with the native host connector, Firefox is going to call close session with the handle of the session. The portal in turn is going to terminate the executable. And the portal informs Firefox that it's all good. Everything is cleaned up. That's essentially how it works. So I'm going to try and demonstrate how it works in practice. So I've got a virtual machine here. Let me. That's coding. Okay, it's not very useful. Okay, so we'll start with Chrome GNOME shell. So in previous versions of releases of Ubuntu, it was the default tool for managing your GNOME shell extensions. Now there is a dedicated application for it, so it's not installed by default anymore. But we can still install it from the archive. Yeah, I've got it installed already because I'm wary of the demo effect. So so that's the Debian package that you install. And we are going to launch Firefox. So Firefox. This is the latest version, 106.0.5. And just to prove my point, this is a snap indeed. Okay, let's launch Firefox. I'm going to browse to About Add-ons to install extensions. I will search for GNOME shell. What? Nope. Let's try again. No. Wrong key. All right, that's the extension we're interested in. So I'm clicking on Add to Firefox. I'm adding it. And right away, I get a pop-up modal prompt asking me whether I want to allow Firefox to communicate with this native connector. So I will accept. OK. There we go. And the extension installed this button in the toolbar. So it allows me to search for GNOME shell extensions, and I can list my locally installed extensions. And as you can see, it is listing these extensions that are installed by default on Ubuntu. And I can enable and disable extensions. All of this is communicating with the native host connector through the portal. I can configure the extension, which is going to launch the configuration dialog for that extension in GNOME shell. OK, so that's for an extension and a connector that is installed as a deb package. Now, we're going to do something slightly more interesting. I have a password manager here called KeePassXC installed as a snap. Yeah, so that's a snap. I'm going to launch it. All right, I've got an existing database for my passwords. Yeah. And I've got one saved password for login.ubuntu.com, so that's my Ubuntu One account. So we are going to make the Firefox extension for KeePassXC communicate with KeePassXC installed as a snap. All right, so let's look for the extension here. That's the extension we're interested in. I'm going to add it to Firefox. Okay, that was added. Okay, so before we proceed to actually, so it installed an icon here. Before we proceed to using it, there's one more step we need to take. We need to open the configuration for KeepaSexy. There is a browser integration tab here, and it's disabled by default, probably for security reasons. So I enable it, and here it says, due to Snap sandboxing, you must run a script to enable browser integration. You can obtain this script from keepasexy.org. So I'm going to click OK. I have the script already downloaded here. It's just a simple shell script. So I'm going to run it here. Essentially, what this script does is just install the manifest file in a place that the portal is going to be able to find. Otherwise, the portal doesn't know how to look for manifest inside strictly confined applications like snaps or flatpaks. That's something that we should look into addressing in the future, but it's not there yet. So this is Firefox, and I'm going to lie. I'm going to say this is not installed as a snap. The reason for this is that if I say yes, it's going to bail out and refuse to install the manifest because it thinks that Firefox as a snap doesn't support native messaging. I've already submitted a pull request against the upstream project to get that removed. It's been accepted, but it's not merged yet. So let's say that no, it wasn't. It's not installed as a snap. And let me show you. It installed the manifest file in .mozilla native messaging hosts, and that's the JSON file. That's what it looks like. And the native connector is this snapbin keepasexy.proxy executable. Okay, so I think we're all set up. Now, all we need to do is to try and communicate here. Let's do reload, and ta-da. We get prompted whether we want to allow the extension to talk to the KeepaSexy proxy. Okay, allow. Now, let me see, connected databases. That's the initial connection. Afterwards, it's not needed. Yeah, so we need to give it a name. Okay, and it says here that I am connected to the proxy through a connection called this. Okay, well, it should work now. Yeah, it's reporting a correct status. So let's just browse to login.ubuntu.com. Okay, cookies, and I get here a prompt by KeepaSexy asking me whether I want to allow this website to access my saved password, user and password information for this website. So I allow it, and there we go. It's auto-filled. And just to prove that it's not actually, it's actually talking to KeepaSexy and not using the logins feature of Firefox. I don't have any logins saved here. All right. Okay, what did I do with my presentation? Did I lose it? Okay, we're done with the demo. Oh, there it is. Okay, so that was the demo. We're almost done. Future work. What's next? Yeah. So there are a few things still to do. So get consensus on the portal, but as I mentioned, it looks like we're getting there. Get it merged upstream so that we can get rid of the distro patch in Ubuntu. That would be a good step forward. Then land the patch in Firefox itself. It's currently available in the snap because we actually apply a patch. There is also something which I didn't mention. So for desktop environments where there is no front end for the access portal, you might not get prompted for permission. And if you're not prompted, the default is to refuse access to the portal. So some users have reported that they weren't prompted and native messaging isn't working for them. So the workaround is to install Flatpak and manipulate the permissions database using Flatpak permissions. But that's a bit confusing for users, right? Especially users of the snap. They don't really understand why they need to install Flatpak to get the snap working. So one thing that we could do about it, maybe, is to extract this tool out of Flatpak. It's there for historical reasons, but it would have it could have a new home in XDG utils or a similar package, probably. That needs to be discussed. That's just rumblings. And more importantly, we need to create a UI in the settings application to actually allow the users to change those permissions back and forth. Then once it's all addressed in Firefox, we would like to replicate this work for other browsers, including Chromium. And I mentioned the warning about snaps and having to lie when you install the connector for KeepaSexy, but that's already addressed. And that's about it.